Why is NumPy vectorization faster than standard Python loops? Imagine trying to fill a large swimming pool with a tiny cup versus a big hose. The hose fills the pool much faster because it moves more water at once. That's similar to what happens with NumPy vectorization compared to Python loops. When you work with large datasets in Python, speed is key. You might think writing a loop to process each item one by one is simple, but it can take a lot of time. Python loops interpret each step, which adds overhead and slows things down. Every time the loop runs, Python has to check conditions, manage control flow, and call functions repeatedly. This process is slow, especially with thousands or millions of data points. NumPy arrays are stored in contiguous blocks of memory, kind of like a row of boxes lined up perfectly. When you perform an operation on a NumPy array, it uses code written in a language called C, which runs outside of Python. This code is optimized to handle many data points at once. So, instead of looping through each element, NumPy applies the operation to the whole array in one go. This is called vectorization. It takes advantage of modern CPU features like SIMD instructions, which can perform the same task on multiple data points simultaneously. Because of this, NumPy can do calculations much faster than Python loops. For example, adding two large arrays together with NumPy is just a single operation on the entire arrays. In contrast, doing the same with a Python loop means executing hundreds of thousands of individual addition operations, which takes much longer. Plus, using vectorized operations makes your code cleaner and easier to read. Instead of writing a loop to square each number in a list, you just write one line with the array squared. However, vectorization works best when the operation can be applied to the whole array at once. If your task involves complex conditional logic or step-by-step calculations that cannot be done in bulk, then loops might still be necessary. But for most numerical tasks in data analysis, NumPy vectorization is the way to go. It saves time, reduces code complexity, and makes your programs run faster. That's why understanding and using vectorized operations is a fundamental skill in Python for data analysis and scientific computing.